Hi and welcome to my latest Lego Technic creation, a 12-speed gearbox. Now this gearbox is based on the previous gearbox I did, which is a 4-speed, and central to this idea was to use the changeover rotary catch, this orange component, to select from one of 4 different speeds. Now what I've done is extended that idea, and I have used 2 of these, and that allows me to select between 1 of 4 over here, and I've chosen to select between 1 and 3 different speeds on the other rotary catch, giving me 12 different combinations, or 12 different speeds. Okay, so I'll give you a demonstration of the gearbox in action. I'll just turn it on. The first gear I've actually selected is the stop gear, so that is 0 speed, and in fact this can't turn. It's got a wee bit of leverage in there, but it's actually a stop rather than neutral. From there we can go into reverse, so this is reverse speed number 1. See it going there slowly, and then we go reverse speed number 2, a little bit faster, and then reverse speed number 3, which is the fastest in reverse. We can then go back to the stop gear, which is right there, and then we can go forwards into gear 1, gear 2, gear 3, gear 4, gear 5, gear 6, gear 7, and finally gear 8, which is the fastest about. Okay, so on this side of the gearbox we've got the input, which is driven by this medium-sized motor on this side. We've got the changeover gear selector, and on the other side we have got the output axle. Now the way the gear selector works is that it's got one of 12 different positions, and as you rotate between the 12 different positions it is selecting between each of the 2 selectors. So here we've got the primary one that's got the 4 different gears on it, and the secondary one that's got the 3 gears, and then what I've got is this knob wheel that every time you rotate the first one around 4 times it will drive the next one around by 1/4. As you can see, 1, 2, 3, 4. We'll push that around, and then the 4 will push that around. So as we rotate between the 4 different positions on the first selector, it will go through 3 different positions on the second selector, giving us the 12 different combinations. I'll just show you there's mini steppers actually hidden behind this front panel here that we can take off. We can remove these 2 gears, and we can carefully pull off this front panel, and that will reveal the 2 mini steppers. So as we turn the gears, you can see the 2 steppers controlling those positions of the selectors in nice neat 90-degree positions. Okay, so looking underneath the gearbox, on the right here we've got that medium motor, which is the input, and that drives the central gear, which distributes to 2 other gears, and they're the main driving gears for each of the selectors. So the red part of the gearbox implements the gearing that's required to generate all the different gear ratios that the selectors select from. So like I said, the primary selector selects from 4 different gearing ratios, and the secondary one from 3. So I'll just show you what those gearing ratios are that have been implemented. So for selector number 1, we've got the 4 different selections, and selection 0 implements 3/5 times 3/5, which gives you 0.36 gearing ratio. Selection 1 is 3/5 times 1/3, which is 0.2. The second one is 3/5 times 1/3, 0.067. And finally the third selection is just simply 0. Which means that that particular axle is actually locked and can't move. The secondary selector, again, has got the 3 speeds. We've got 0 again, we've got 1/3, and finally 3/5. So the outputs of the selectors actually drive a differential tucked in the middle here. So this top one drives one of the sides of the differential, and the second selector drives the center of the differential. And you can see, maybe from this angle, you can see the differential sitting there, and that drives the output of the gearbox. Now if you recall the relationship between the input and output of a differential, which is given by this equation here. So we've got a differential, we've got 2 inputs A and B, then the output C is given by the average of the 2 inputs A and B. So C, which is the output, is given by A plus B divided by 2. and if we rearrange that equation we can get B equals 2 times C minus A, which is what we've used for this gearbox here. What I've actually done is that selector 1, like I said, drives one of the sides, selector 2 drives the center, and the output is given by this relationship here, B equals 2 times C minus A, or in other words, it is 2 times selector 2, take away the output of selector 1, gives the overall output of the gearbox. So the final output ratios of the gearbox are given by the two selectors, and the relationship between the differential outputs is shown in this big table here. So again, we've got selector 1 and selector 2. Selector 1 goes through 4 different selections and then repeats. So we've got 0, 1, 2 and 3, 0, 1, 2, 3. Then as it goes through the first set of selections, selector 2 gets activated, going from 0 to 1, and similarly from 1 to 2. And R1 and R2 are the ratios that each of these selectors implement, and by putting that through that differential, this relationship here, we get 2 times R2 minus R1 to give us the final output. So for example, if selector 2 and 1 are both set to 0, then R2 selects 0, R1 selects 0.36, and that gives us a final output of 2 times 0 minus 0.36, which gives us that reverse 0.36 gearing ratio. Similarly, when we go from 0 to 1, we've got R2 being 0, R2 being 0.2, and we get 2 times 0 minus 0.2 gives us an output of minus 0.2. So that's the second reverse gear, which is going a little bit slower. We can do the same and work out that the third reverse is minus 0.067, so that's quite relatively slow. We then here we've got our stop gear, where both are selecting the 0 output. Once we go, selector 2 goes to 1 and selector 1 goes back to 0, then we're selecting a third and 0.36, so we've got 2 times a third minus 0.36 gives us the first forward speed of 0.307. And the same, we can go through all the different speeds in a similar manner, and we find that we get 0.307, 0.467, 0.6, 0.666, 0.84, 1, 1.13 and 1.2 being the 12 different possible gears, which is the 3 reverse, the stop and the 8 forwards. That explains the 12-speed gearbox. Hope you enjoyed this video, and please support this channel by subscribing or leaving a like. Thanks very much.